Exercise 196, page 488, question number 5. Integrate 3t squared e to the 2t. This is an interesting one. Remember, the whole idea of this is whatever I call u, when I differentiate u to get du, that should make it an easier integral to do. Well, if you look at this one, if I let u equal 3t squared, differentiating that, it's going to give 6t, which is still going to require integration by parts. But if I differentiate 6t, then I get rid of the t. So integration by parts will work, but I've got to go through the process twice to do it. So that's going to make it quite a long question to do, but it's just a case of following the technique through twice. If this term was a 3t cubed, then I'd have to go through the process 3 times, and so on. So what I'm going to do is let u equal 3t squared, which means that du by dt equals 6t. So if I'm letting that first expression equal u, then dv equals e to the 2t, which means that v equals a half e to the 2t. Putting this information into the integral, we get that the integral of 3t squared e to the 2t dt, the original integral, equals u, which is 3t squared, times v, which is a half e to the 2t, minus the integral of v, which is half e to the 2t, times du, which is 6t dt. Tidying this up, 3 times a half is 3 over 2, t squared e to the 2t, minus, well, I can take the 6 over 2 outside, a half times 6 is 3, times the integral of t e to the 2t dt. But this, again, requires integration by parts. So for this one here, I'm going to let t equal u and dv equal e to the 2t. So looking at this one, I'll let u equal t, which means that du by dt equals 1. So dv equals e to the 2t. So v equals a half e to the 2t. Putting this information into the integral, we get, rewriting this first part, so the integral becomes 3 over 2 t squared e to the 2t minus 3. Now, using integration by parts, uv minus integral v du, so it's u, which is t, times v, which is a half e to the 2t, minus the integral of v, which is a half e to the 2t, e to the 2t, times du, which this time is just 1. So now we get to one we can do. So the final answer becomes 3 over 2 t squared e to the 2t minus 3, closing this bracket here, minus 3, a half t e to the 2t minus this integral, I'm going to take the half outside, and then e to the 2t again becomes a half e to the 2t, all plus c. So you can see it's quite long and you've got to be careful not to make mistakes. So expanding out these brackets, we get 3 over 2 t squared e to the 2t minus 3 over 2 t e to the 2t minus 3 times minus a half is plus 3 over 2 times a half e to the 2t plus c. I can multiply that bracket out as well, so this leaves 3 over 2 t squared e to the 2t minus 3 over 2 t e to the 2t plus 3 over 4 e to the 2t plus c at the end. So we can factorise to try and make this a bit more straightforward. We can take a 3 outside and we can take a 2 outside. So that's 3 over 2 e to the 2t into t squared minus t plus a half plus c. Quite long, but it's just a case of following this procedure and just being careful you don't make mistakes. Let's hope I haven't made any.